This is the second lesson of Unit 5 on zero and negative exponents. So we're going to start by completing the following chart. It says evaluate each to standard form and leave as whole numbers or fractions. So no decimals here. Okay, so we can see this first example. It says the expression to be simplified is 2 to the power of 3 over 2 to the power of 1. So we wrote that in expanded form, right? So 2 to the power of 3 means 2 multiplied by itself 3 times, divided by 2 multiplied by itself just once, so just 2, and that equaled 4. And then we used our exponent laws. So because this is division, what we did is we subtracted our exponents, right? So 2 to the power of 3 minus 1 is the same as 2 to the power of 2, which gave us that same answer as 4. So we're just going to continue doing that with our questions here. So in expanded form, again, this part is easy. You're just writing it out however many times it tells you to. In this case, 3 and 2. So that is going to leave me with 8 over 2, 8 over 4. 2 times 2 is 4, which is the same as 2, right? 8 divided by 4 is just 2. If I were to use my exponent laws, I have 3 minus 2, which is the same as 2 to the power of 1, which is 2. Okay, moving on to the next one here. 2 to the power of 3 divided by 2 to the power of 3. So 2 times 2 times 2 divided by 2 times 2 times 2, which is 8 divided by 8, which is just 1. So if I were to use my exponent laws, I have 3 minus 3, which is 2 to the power of 0, which if you type into your calculator, you will get 1. So the next one, 2 times 2 times 2, divided by 2 times 2 times 2 times 2. So here, I have 8 over 16, which is the same as a half. Okay, if I do my exponent laws, I have 3 minus 4, so I have 2 to the power of negative 1, which we will learn is the same. Actually, we'll just wait. We'll leave it and we'll come back to it after we learn the law. Okay, so same with this one. So 2 to the power of 3, so 3 times over 5 times. So 2 times 2 times 2 times 2 times 2 is 8 over 32, which is the same as 1/4. So if I use my exponent laws, I have 3 minus 5, which is 2 to the power of negative 2. Okay, awesome. So it says, how is the exponent law expression related to the expanded form expression? So the exponent law is the last column here, and saying how is it related to the expanded form? Well, this is pretty simple, right? We don't have to think too hard about this. Obviously, they're going to give us the same answer, whether we do the expanded form or the exponent form, right? We're getting the same answer regardless. So you don't really have to write anything there. The next question says, what do you notice about the result of an expression with an exponent of 0? So that's this one here. Okay, and what we can notice is that it equals 1, right? So we would write that in. It equals, or it is equal to 1. Okay, and then it says, what do you notice about the result of an expression with an exponent that is negative? So now we're looking at these two here. So we can see those are both negative. And if we look at the expanded form, we notice that you get a fraction, right? So they result in a fraction. Okay, so the 0 exponent, to summarize here, any number or expression divided by itself is going to be equal to 0. Okay, so it says use exponent laws to evaluate each of the following. So here we have any number divided by itself, right? So 2 to the power of 3 divided by 2 to the power of 3, we know is going to be 2 to the power of 0, which if we type that into our calculator, we will get an answer of 1. Same thing here, right? 2 minus 2 is 0, so we have 3 to the power of 0, and we know that that will equal 1. And lastly, x to the power of 4 divided by x to the power of 4, again, is going to be x to the power of 0, which gives us an answer of 1. So therefore, any base raised to an exponent of 0 is going to be equal to 1. Okay, so a to the 0 as a general formula will always be 1. So if we're looking at these examples down here, 7 to the power of 0, we don't even have to use our calculator, right? We know that that's going to equal 1. X to the power of 0 is going to be 1. This one, we have 3 times 2 to the power of 0. So we have 3 times 1, right? Because anything to the power of 0 is 1. So that would be 3. Here we have x to the power of 0 times y. X to the power of 0 is 1 times y is just 1y. Okay, so that's the first half of this note. That's the 0 exponent. So give me a second to pull up the other half, where we will be discussing that negative exponent. So any base raised to a negative exponent is equal to the reciprocal of the base raised to the same positive exponent. Okay, and that's kind of a confusing definition, so make sure you pay attention to the example here. So the reciprocal, all that means is you have to flip the fraction. The reciprocal is just a flipped fraction, okay? So if we have a to the power of negative m, anytime that we have a whole number without anything under it, we can always assume that it's over 1, right? So if I were to flip this fraction, my 1 would be on top and my a would be on the bottom. And as my definition says, now it becomes raised to the positive exponent. So I'm getting rid of that negative by flipping my fraction over. My exponent will become positive. Okay, it will work the same way if you have a fraction. So if you have 1 over a to the power of negative m, what we need to do is we need to flip it, and then we can write the exponent as positive. So if I flipped this, I would have a on top, 1 on the bottom, and my m becomes positive. Okay, and obviously for this one, we never really write that 1 on the bottom unless we have to. So this is just equal to a to the power of 1 of m. Okay, so let's practice this in some kind of real situations here, real examples, so you can kind of understand. So it says use exponent laws to simplify each of the following, then evaluate to standard form. So we're going to start with our exponent laws. So here we're dividing, which means we need to subtract our exponents. Okay, so 2 to the power of 3 minus 4 is 2 to the power of negative 1. Okay, so to write that into standard form, using what I have right above me here, looking at this first one, this first example. So a to the power of negative m, right? In this case, my a is 2, my negative m is negative 1. So what I need to do is I need to flip it, right? So I imagine that there's a 1 underneath here, and I flip it over. So the 1 comes on top, the 2 goes to the bottom, and now it's to the power of positive 1. Okay, let's do another one. So here we have 2 minus 5. That's a 5, not a 3. 2 minus 5, which is 3 to the power of negative 3. So again, all I have to do is I have to flip it over. So I have 1 to the power of 3, 1 divided by 3 to the power of positive 3 now. And I can take that a step further, right, to simplify it. 3 to the power of 3 is 9. Okay, last example. Here, again, the bases are the same, so my exponent law is to subtract the exponent. 5 minus 7 equals 4 to the power of negative 2. But I don't want that negative, so I just simply flip my fraction over and simplify. Okay, so it's just a matter of switching the order of these two, right? Just switching them. Once you switch them, remember, the reason we're doing that is so we can write that positive exponent. So don't forget that step, because that's the whole purpose of this. Okay, so a couple more examples. So if we just have 7 to the power of negative 1, it just wants us to simplify and then evaluate. So we're not just going to type this in on our calculator. Instead, we're going to write it as a positive exponent. Okay, and remember, picture it over 1, flip it around. So the 1 comes on top, the 7 goes to the bottom, the exponent becomes positive. So this is just 1 over 7, right? 7 to the power of 1 is 7. This one here, don't get confused because it's a negative 8, okay? It works the same way. You write the 1 on top. You're not changing the sign of your base. What you're changing is the sign of the exponent. So that becomes negative 8 to the power of 2. If you typed that into your calculator, you would get, and you don't have to type in 1 over, right? You would just type in 8 to the power, or sorry, negative 8 to the power of 2, which gives you 64, because we want to leave it in a fraction. We don't want to deal with decimals here. Okay, so same thing here. Picture it over 1, flip it over. That negative 3 becomes positive 3. Type 2 to the power of 3 into my calculator, which is 8. Same thing, picture it over 1. 1 comes on top, negative 3 comes to the bottom. My power that was, or my exponent that was negative 3 becomes positive 3. Typing just the negative 3 to the power of 3 into my calculator to get negative 27. Okay, so try to fill in the following table without me giving you the answer. So maybe just pause the video so you can take a chance to try to figure that out. And then obviously come back to double check your answer. So it's asking us basically to go back and forth from exponent form to simplified form. So simplified form is just like when you fully evaluate it. So it's just going to be a number or a fraction. So if we do 3 to the power of 2 on our calculator, we know that that's just 3 times 3. So really we should be able to do it in our heads. 3 times 3 will give us 9. Okay, so I'm just going to do that, like the ones that go from exponent to simplified first, because I think they're the easiest. Okay, so anything to the power of 0 is 1, right? Anything to the power of 0 is 1. And these two are a bit more tricky. Okay, so we'll leave them for a second. So I'm going to go back to the start. So I'm trying to write 1 over 5 in exponent form. So basically we're just working backwards from what we were doing above, right? Because look at this example here. 7 to the negative 1 gave me 1 over 7. So that means if I do 5 to the negative 1, it would give me 1 over 5, right? Because, excuse me, I would flip this. So it would become, the 5 would go to the bottom, the 1 would go on top. So that's 1/5. My negative 1 exponent would become positive 1. 5 to the power of 1 is 5. Okay, same with this next one. So 3 to the power of negative 3. That's going to be very similar to what you see above here, right? So we know that we have to flip the fraction. And that will make my exponent positive. 3 to the power of 3 is not 9. 3 times 3 times 3. 9 times 3. 3 to the power of 3 is 27. That makes more sense. 1 over 27. Okay. So 1 getting a fraction of 1/3, we just have to go the reverse, right? So we're going to flip it, and instead of the fraction being to negative or to positive 1, it would become -1. Okay, here same thing, we just write the 1 on top. Even though my exponent is a variable, that's fine. My negative n becomes positive n. Okay, here 5 to the power of m, or sorry, 1 over 5 to the power of m. Again, just flip it. So we have 5 to the power of -m. Okay, so hopefully you were able to fill in that chart given the information that you've learned in this lesson. Okay, simplifying expressions. So it says, the rules for positive exponents also work for 0 and negative exponents. Continue to follow the rules for order of operations when simplifying and evaluating. So these are going to be kind of the most complicated ones we're going to get, right? Where we're going to have to apply the different exponent rules as well as that 0 and negative exponent rule that we just learned in this lesson. And we need to make sure we're following BEDMAS. So in this case, we don't have brackets, so we're going straight to exponents for this first example here. Okay, so we have 3 to the power of 3 times 3 to the power of -5. So because we're multiplying, we know that our exponent rules encourage us to add, right? Or they don't encourage us, they tell us we need to add our exponents. So here we have 3 to the power of 3 plus -5. Okay, 3 plus -5 is the same as 3 minus 5. So that gives me 3 to the power of -2. Okay, remember, you're not just going to type this in on your calculator. We need to make sure that we're not writing these in decimals, we're using fractions. So our negative exponent rule tells us that we can just simply flip this fraction over and make our exponent positive, right? So this is going to be the same as 1 to the power of, 1 divided by 3 to the power of 2. 3 to the power of 2 is 9. Okay, so we can simplify this expression from 3 to the power of 3 times 3 to the power of -5 all the way to a single value of 1 over 9. Okay, so let's try this next one. So again, we don't have any brackets, right? Those brackets are just indicating that that negative sign is attached to the 2. So we are dividing here, which means we need to subtract our exponents. So we have -2, 2 minus -3. Okay, so 2 minus -3, those two negative signs actually result in a positive sign, right? We're actually just adding here. So 2 plus 3 is 5, so we have -2 to the power of 5. So we can just simply type that in on our calculator and we will get -32, okay? Because I have a positive exponent, I don't need to use that negative exponent rule at all. All right, last example here. So again, we need to use BEDMAS here. So that means we need to simplify our brackets first. Okay, so we have 3 to the power of 2 divided by 3 to the power of 4. Okay, because we're dividing, that means we need to subtract our exponents. I'm going to keep this in brackets. So I have 2 minus 4, and then on the outside I have to the power of 2. 2 minus 4 is -2 to the power of 2. Okay, so what I need to do now is I need to do -2 times 2, right? Because that's our power of our power. So when we have power of a power, we know we have to multiply. So I'll show you the step. So that will give us -4. But again, we don't want that negative exponent. We know that it's easy. All we have to do is flip our fraction over and our exponent will become positive. Just simply typing in 3 to the power of 4 in our calculator, you will get 1 over 81. Okay, so these last examples kind of combine all of those power rules together, so you will have to know how to do that, so make sure you practice that. Okay, this is the end of the second lesson of Unit 5 on negative and 0 exponents.